Question is, two bodies were thrown simultaneously from the same point, one straight up and other at angle theta is equal to 60 degree to the horizontal. The initial velocity of each body is equal to v0, which is 25 meter per second. Neglecting the air drag, find the distance between the two bodies at time is equal to 1.7 seconds later. Take g as 10 meter per second square. So in this case, first of all, we are going to draw the figure. So we have two bodies. One is thrown vertically upward. Let us suppose it is body A, which is thrown vertically upwards, and another body is thrown, body B, which is thrown at a angle of theta with the horizontal. And let us suppose after time t, the object or body B reaches the point D, and after time t, body A reaches the point E. So let us assume this is X and this is Y. So in case of body A, as it is thrown vertically upwards, so we are going to use the relationship S is equal to ut plus half gt square. So if we say this is height h, then h will be equal to, with the initial velocity is given as 25, this is 25, time is given as 1.7 minus 1/2, g is given as 10, time is given as 1.7 square. So h will be equal to 42.5 minus 14.45, which will be equal to 28.05. So if you assume that this is point origin, then the coordinate of E will be given as 0, 28.05. So now let us take for body B. So in case of body B, let us first of all find out its coordinate. So in the horizontal direction, that is u of x, will be given as u of x cos of 60, and this will be equal to 25 into 0.5. This will be equal to 12.5 meter per second, and in the vertical direction, u of phi, we can write u of phi sine 60, which will equal to 21.65. So the distance traveled in the horizontal direction, let us suppose it is written as s of x, which will be equal to u of x, that was 12.5 multiplied by time t 7, so this will be equal to 21.5. And in the vertical direction, s of y will be equal to uyt minus half g t square. So u of y is 21.65. This is multiplied by 1.7, and we already know that half gt square is equal to 14.45. So we simply substitute 14.45. So we can write that S of y is equal to 22.35. So we found out that S of x, which was nothing but x coordinate, and S of y, which was a y coordinate. So we know point D, whose coordinate is given as x comma y. So coordinate D will be equal to 21.5 and 22.35. So now we are going to find out distance. Distance means distance DE is equal to x2 minus x1 whole square minus, plus y2 minus y1 whole square and its square root. We substitute the value, we get 21.5 minus 0 square plus 22.35 minus 28.05 whole square root. This will be equal to 49.4 square root, and approximately that can be written as 22 meters. It means the distance after time t between the two bodies will be equal to approximately 22 meters. Thank you.